Okay, let's answer the second question. We have a balloon type apparatus is used to determine an in-place unit weight for a soil or field density test. The volume of the test hole determined by reading the water level graduations on the apparatus cylinder before and after digging the test hole is given 0.000708 cubic meters. The wet weight of the soil obtained from the test hole is 1,410 grams. And then the soil sample was dried on a fieldstone and weighs 1,237 grams. And we have to compute for these unknown parameters. We have the water content of the tested soil, the in-place dry unit weight of the tested soil, and then the percentage of compaction for the test result if the soil is part of a compacted earth field whose maximum unit weight from the laboratory compaction test is 18.57 kilonewtons per cubic meter. Okay, so to answer this question, first is to list down all of the given parameters. Meron po tayong tatlong values na binigay. We have the volume of the test hole. So, galing po siya kay hole or test hole, ibig sabihin, in its natural state po yung ating lupa. Pag natural state, meron po tayong tubig doon. Therefore, yung volume na yun will be the total volume parameter. And that is 0.00708 cubic meters. And then the wet weight of soil is given also. Since wet pa rin tayo, may tubig po, that will be a total mass parameter. Mass po kasi in terms of grams yung ating unit. So that is 1,410 grams. And then it is oven dried or dried on a fieldstone. Pag drenay po natin, mawawala po yung tubig. So matitira lang po sa ating soil will be the solid particles. So mass of dry soil or soil particles or solid is 1,237 grams. First is to compute the water content. And we know that from our first topic, soil properties, omega or water content or moisture content is the ratio of mass of water with respect to mass of soil particles. Yung mass of soil particles given na po sa ating problem. Yung mass of water, makukuha natin yan pag i-deduct natin mismo yung total mass and then yung ating mass of soil particles. So, over mass of soil particles. So, lahat na meron po tayo. So, by substituting, moisture content is 1,410 grams minus 1,237 over 1,237 grams. So, computing, we will get moisture content equivalent to 13.985%. Naka-percentage po palagi ang moisture content. Pero depends pa rin po kung ano yung given sa mga choices natin. So, pwede rin naman po naka-decimal form. So, that will be our first requirement. Second requirement, in-place dry unit weight. Again, from the soil properties formulas, dry unit weight is equivalent to the ratio of weight of soil particles with respect to the total volume. Yung total volume given na po sa ating problem. Yung weight of soil particles, wala pa. Pero pwede natin i-relate with respect to the mass of soil particles dahil ang weight is the product of mass with respect to gravitational product of mass of soil particles and gravitational acceleration. So, over total volume. So, meron na po lahat tayo niyan. Given na yung mass of soil particles, total volume, and this is a constant parameter. So, by substituting, MS is 1,237 grams multiplied by 9.81 meter per second square over total volume 0.00708 cubic meter. Pag sinabing unit weight, dapat yung unit po natin ay in terms of kilonewton per cubic meter. So, naka per cubic meter na po tayo. Pero yung ating numerator unit, hindi pa po naka in terms of kilonewton. So, convert grams into kilograms. 1 kilogram is to 1,000 grams. Cancelled na po yung gram. Kilogram meter per second square is Newton. Make it kilonewtons multiplied by 1 kilonewton is to 1,000 newton. So, makakancel yung meter per second square, kilogram, and then newton. So, the unit will be kilonewtons per cubic meter. And by calculating, the answer for the dry unit weight will be 17.1397 kilonewtons per cubic meter. The answer for the second requirement. And then, the third requirement, percentage of compaction. Yung percentage of compaction, balik tayo sa ating mga formulas, that is also the relative compaction. And that is in terms of percentage or in terms of percentage form. And that is the ratio of gamma dry in the field with respect to gamma dry in the laboratory in maximum condition. And then, multiply lang natin ng 100%. Yung field dry unit weight natin, ito na po yung nakuha natin, 17.1397. Kasi nga, etong ginawa natin, yung test is field density test. At yung nakuha natin na dry unit weight will be the field dry unit weight ng ating soil. So, computing relative compaction, that is the ratio of gamma dry determined in the field, then gamma dry maximum determined in the laboratory. So, relative compaction, nakuha na natin yung field dry unit weight, 17.1397 kilonewtons per cubic meter over yung maximum dry unit weight determined in the laboratory given na sa ating problem. That is substituting 18.57 kilonewtons per cubic meter. So dividing, and then you have to multiply it by 100%. And then the relative compaction will be 92.298%. And that will be our third requirement.